Peter tossed out some bait this morning, but nobody else would rise, so fools always step in where angels fear to tread. Let me go back to the question of what is meant by disturbed and quiet. I remember some years ago, Walter Becker looked through 10 years of KP records, and he found a few days with the very lowest available values, and on 3 of those days he found a period where the whole ionosphere was lifted up by nearly 100 kilometers and plonked down again. So this opened the question of what is meant by quiet and disturbed. And I think Vassiliunas just said it. Let me rephrase it, if I may. If you imagine the magnetosphere is like a bathtub, there is one phase where the tap's turned on and the tub fills. And it may be, as we heard Pat describe this morning, that you need some turbulence in order to get the particles in. And then somebody pulls out the bung, and the bathtub empties. Now, which are you going to call the quiet, and which are you going to call the disturbed condition? Is the disturbed condition when the bathtub empties? Is the disturbed condition just that short period where the plug is pulled and the substorm is triggered? Or are you distinguishing between some time when the tap is turned on with rather more force and you get the thing filling more rapidly, or where the hole is a little bigger and it empties more rapidly? What do you mean by quiet and disturbed, and can you order the situation a little bit better in terms of the phase where the particles are entering and the magnetosphere is filled or inflated or whatever word you want to use, and the phase where it's dumped and emptied into the substorm?
These hydraulic analogies can give one a sinking feeling, I suppose.
What I would like to discuss tonight is an announcement of flight opportunity that is soon to be released from NASA that will cover a very large number of satellites. As a matter of fact, I have to say in all candor, it's the most sweeping announcement of flight opportunity I've ever seen. But in the Explorer class series of satellites, a general announcement will be issued, and it will call for solicitation of experiment ideas for 4 major Delta-class satellites. And 3 of them are in the field of astronomy. An X-ray and gamma-ray time correlation explorer, an infrared telescope, and a low-energy X-ray EUV telescope. And the 4th is in our area, and it's an electrodynamics explorer. What is Electrodynamic Explorer? Well, it's 1 or 2 spacecraft. And the basic spacecraft will be quite similar to the Atmosphere Explorer spacecraft, like AEC, which is up in orbit now and which is soon to be followed by AE, D, and E. And the features of this spacecraft are that it weighs in the neighborhood of 800 pounds, and it's capable of carrying about 200 pounds of scientific experiments, and it has roughly a 2-year lifetime, give or take a year. And its primary feature, in addition to this, which makes it sound a lot like the IMPS, is that it has an onboard propulsion system which is capable of permitting the spacecraft to vary its orbit. The first view graph is an attempt to show what the orbit of Electrodynamics Explorer might be. This is just a sample cross-cut of the magnetosphere, and the only thing important is... Can you back the gizmo a little bit?
Okay, enough.
Okay.
Beautiful.
That's good enough. All right. The primary region of interest will be if we concentrate on this magnetic field line, which is supposed to be roughly descriptive of the L equals 4 or thereabouts field line. In other words, roughly we're looking at the edge of the plasma pause. The orbit talked about most frequently for Electrodynamics Explorer is a polar orbit with about a 4 Earth radii apogee, and the nice characteristic of such an orbit is that over most of the orbit the spacecraft is following a magnetic field line. Now this is the orbit of the Electrodynamics Explorer A, which I guess I have to say in all candor may be the only Electrodynamics Explorer. If there's an Electrodynamics Explorer B, it will be, the spacecraft itself and the instruments will undoubtedly be very similar to A. And the orbit of Electrodynamics Explorer B is essentially anything that the scientific working team thinks may make sense. The generic types of experiments which EE could accommodate would be electric and magnetic field experiments. And this is kind of important because those of you who are familiar with AE know that that AE doesn't have any long booms on it because of problems associated with buffeting low down in the atmosphere. Electrodynamics Explorer will permit long booms to make electric field and magnetic and sensitive magnetic field measurements. There could be a TV, although I say that rather guardedly because this would be a major contribution of the weight of the scientific payload if that decision were made. There would be particle spectrometers for both protons and electrons, some kind of a cold plasma instrument, and presumably spectrometers to look in the UV and IR ranges. And there could be many other things depending upon what kind of proposals might come in to NASA. The launch date that would be most reasonable, realistically, would be in about the 1978 to 1980 time period. And this would be a Delta satellite launch. The procedure for selecting the payload, as I said, there will be an announcement of flight opportunity that you can expect to see in about perhaps 1 to 3 months from now. We have been accused many times of being too rich in satellites in our discipline, and we sometimes get accused of being used car salesmen when we try to put forward another one. But I think this one is unique, and I'm very optimistic about its prospects.
Thank you, Larry. I'm overwhelmed by this announcement in view of the past 5 years or so.